Hi, we are going to briefly discuss general tree in this video. So general tree is covered in CS3B, both the concept as well as the implementation. So here we'll just review a little bit of the terminology, but we won't get into the implementation details. And a general advice for studying trees and really data structure in general is you need a lot of papers and pen and pencils, and then you want to draw lots of pictures. So trees. This is a tree that we probably all seen in high school or college biology class. It's a classification of animals. At the top, it's well, animals, and then vertebrates, invertebrates, and then further um, breaking down into other categories. So the animal classification is, is stored and visualized as a tree, and it's kind of a upside down tree. It's not the normal tree that we see in our backyard or in the park. That it's upside down, as most trees in computer science that you encounter, they're upside down trees. Now, tree is a what's called an abstract data type, and it supports a bunch of operations such as insertion, removal, or traversal, which is allowing all the data to be iterated over. Okay, and other examples of trees. So if you have a Mac, you can in any open a terminal, or a Linux machine, open a terminal. In any of the directory, you can issue the tree command, and it actually shows you the entire directory tree. More examples. This is a game tree, and in particular for the tic-tac-toe game, it's it's a fairly simple game, but as you can see, even for something as small as that, as simple as that, the tree can grow very quickly, and this is just a small part of the game. Okay, more examples. This is a tree that can be potentially used in writing a Python interpreter, that it can represent a arithmetic or algebraic expressions. And this type of tree, because each node has at most two children, this is actually what's called a binary tree. And now let's get our terminology for trees right. So trees are made of nodes. Each of these little circles, they hold their nodes, and they hold data. Now there is one node in the whole tree that is very special, and that is the node at the very top of the tree that is called the root. Again, because it's upside down, root is not at the bottom, it's at the top. And there is only one root per tree. Okay. And underneath the root, then there's the child nodes. C is a child of A. And then it can be also parent nodes. And C, well, I and J and K, they're all child nodes of C. Conversely, C is the parent node of I, J, and K. And then there are these nodes called that are siblings, I, J, and K, because they have the same parent. So I is the sibling node of J and K, and so on. And finally, there are these leaf nodes that only has parents, but they don't have child nodes of their own. So these are at the very bottom, that has no child. And then this is one big tree, and then there are subtrees, right? And each subtree would have its own root. So for example, a subtree here has with the root that is G. So the subtree of G, it would include G and all the nodes below it. And then same thing here for the subtree that starts at C, it's the node C with all the nodes below C. And we can talk about the size of a tree. The size of a tree is just the number of nodes. So size of this entire tree, if you count it, is 14. You can talk about size of the subtree as well. So size of this subtree is 3, and size of this subtree would be 4. And then there is the depth. Depth is counting from the top of the tree going downwards. So the root of the tree is at depth 0, and then you go down at 1 level. All the children of the root is at depth 1. All the children of the root is at depth 2, and so on and so forth. So depth is really just the number level below the root. So it's all relative to the root. There's another similar concept but different. This is the height. So instead of going from top down, this is going from the bottom up. The height is the number of levels to the deepest node. So pay attention to that. So it's different. So for example, the height of E to its deepest node, which is, I think that's a L. So that's at height 1. And B, for B, the deepest node reachable from B would be M, N, or L. So, and it's 2 levels away. So B is at height 2, and A is at height 3. Okay, so that should make sense. But the next one, just pay attention to this. What about C? What is the height of C? So the deepest node reachable from C is I, right? And C is just 1 level away from I. So C is only at height 1 relative to I. Okay, so I think one more. And if you look at, let's say, the node D, D is at the very bottom. So there's nothing below D, so D itself is at height 0. Okay, so I think that's all the terminology that we need to know about trees.